Hi, in this video we are going to learn how to find the sum of an infinite decreasing geometrical progression. What do we mean by infinite decreasing geometrical progression? It is a geometrical progression with infinite terms and it is decreasing. That means the value of r, that is the common factor, is actually a proper fraction, right? So how do we write a geometrical progression? We write a geometrical progression as AR square, AR cube, AR to the power 4, and so on. It has infinite terms, so last term cannot be found. And what do we mean by decreasing geometrical progression? In decreasing geometrical progression, this value of r is actually a proper fraction. What is a proper fraction? A fraction which is in the form of n by d, where n is the numerator and d is the denominator. It is called a proper fraction when the value of numerator is less than the denominator. Then only it is called a proper fraction. So what are we saying? That if the value of r is a proper fraction, then this geometrical progression will be a decreasing geometrical progression. Decreasing geometrical progression means the value of second term will be less than the value of first term, and the value of the third term will be less than the value of second term. Suppose if we have the value of a as 4, and if we consider the value of r as 2, the series will be 4, that is the first term. Second term will be ar, that will be 8. Third term will be ar square, that is 4 multiplied by the square of 2, that is 4 fours are 16, and fourth term will be 32, and so on, right? And what will happen if I take the value of a as 4 itself and the value of r I take as 1 by 2? This pattern will be, first term will be a, which is 4, second term will be ar, which will be 4 by 2, that is 2, right? Third term will be 1, fourth term will be 1 by 2, right? And fifth term will be 1 by 4, and sixth term will be 1 by 8, isn't it? If you see carefully in this pattern, the value of the next term is always more than the previous term, and in this pattern the value of next term is always less than the value of its previous term. Why? Because here the value of common factor, or r, is a proper fraction. So this is a continuously decreasing pattern or continuously decreasing geometrical progression, and this is continuously increasing geometrical progression, right? And in this video we are actually going to talk about this progression. What happens if we add infinite number of terms of this progression? Let's erase all this. And what we are aiming to find? We are aiming to find the sum of this pattern. So let the sum be s equal to a plus ar square plus ar cube plus ar to the power 4, and this will continue till infinite terms, right? And we had the formula to add the n number of terms of any geometrical progression. And what was the formula? The formula was s equal to a multiplied by 1 minus r to the power n divided by 1 minus r, right? This can also be written as a by 1 minus r minus ar to the power n divided by 1 minus r. This is just the modified form of this formula. And what do we have here? Here we are finding the sum of infinite terms of a decreasing geometrical progression, right? And as we have discussed, that decreasing geometrical progression is when r is a proper fraction. That means the value of r is less than 1. So if the value of r is a proper fraction, or the value of r is less than 1, value of r to the power n will be much lesser than 1, right? Suppose if we consider the value of r as 1 by 2, as we have taken in previous example, r to the power 4 is what? It will be equal to 1 by 2 to the power 4. which is nothing but 1 by 16, right? But what will be the value of r to the power 8? This will be equal to 1 by 16 square, and this will be equal to 1 by 256. So which is lesser? Yes, definitely. Here, if we see carefully, r to the power 8 is much lesser than r to the power 4, right? And so, if we continue to increase the value of n to infinity, we can reduce the value of r to the power n to 0 or to a negligible value, right? So when we have r as a proper fraction, or when the common factor of a geometrical progression is a proper fraction and we are adding the infinite number of terms of that progression, then this value can be made negligible, right? Why? Because this n becomes infinite, and when the value of r is a proper fraction, this value of r to the power n becomes negligible, and that in turn make this whole fraction a negligible value. So in that case, when we have an infinite decreasing geometrical progression, the sum will approximately be equal to a by 1 minus r. Why? Because this portion of the formula becomes almost equal to 0, becomes negligible. So this is the formula to find the sum of infinite terms of a decreasing geometrical progression. And in next few videos, we are going to take few solved examples. So don't miss them. Bye bye.